Hi everybody, we're taking notes in section 8.7. It might be on page 52 of your yellow packet, but it will start with the word day 3, putting it all together. So as I said in the past, you've always had hints when solving. So now you're not going to have any hints. Miss Golly's not going to give you any factors beforehand, or she's not going to be giving you any solutions beforehand. You're going to have to come up with all of them yourself. So what we have is a 5-step process: Descartes rules of signs, rational root theorem, the factor theorem my way, not just any old way, synthetic division until we depress it to an equation to which we can then solve through any quadratic method. The first kind of step 0 would be to say, how many solutions should this have? So that means we're going to come up with 3 solutions here. So let's use all our hints to find out what those 3 solutions are. So first we start with Descartes' rule of sign, and what we notice over here is we have how many variations of the signs. We have 1 variation, we have 2 variations. That means for us that we have 2 potential positive roots or 0 potential positive roots. And then in addition to that, we're going to do it, so maybe we'll be looking for 2, or maybe we'll stop and don't look for them at all. If I plug in p of negative x here, we'll use Descartes' rule of sign to see how many potential negative roots. So plugging that in would give us negative 2x cubed minus 3x squared minus 2x plus 2. So let's count that number of variations. 1, only 1, which means there's 1 potential negative root. Actually, it doesn't mean it's potential. It means there's actually 1 negative root. So if we were going to do that chart where we're saying positive, negative, and imaginary, we would say that there's 2 or 0 with a 1 and a 1. So that gives me a 2, 1, 0 or a 0, 1, 2. So I think I'm hedging my bets on the negative that I would want to search for, because I don't know if there's going to be a positive root. So the next thing I'm going to do to narrow it down is to do the rational root theorem. So the rational root theorem would mean, let's take the factors of this 2, which are plus or minus 1 and plus or minus 2, and the factors of this 2, which we call this n over d, and that is plus or minus 2 over plus or minus 1. So this plus or minus 1 over this plus or minus 2, this plus or minus 2 over this plus or minus 2, plus or minus 1 over plus or minus 1. You don't have to put plus or minus twice, sorry about that. Plus or minus 2 over plus or minus 1. So there almost looks like there's 8 roots to try for the rational roots. These won't tell you the irrational roots. But lo and behold, because these 2 are the same, there is only going to be 6 roots to try. So of the 6 roots to try, 2 of them might be positive or 0 of them might be positive, but I sure know 1 will be negative. So before I start trying something in the cubby over here that might be negative, I'm just going to wait on that for a second, because I'm going to do the factor theorem my way. And here's a the reason I want to do p of 1 and p of negative 1, it's because they are easy and they are quick. Easy and quick. And here's how they are easy and quick to do. P of 1 is just going to be the coefficients of p of x. So you just say 2 minus 3 plus 2 plus 2, and you quickly get a 3. P of negative 1 will be the coefficients of p of negative x, giving you negative 2 minus 3 minus 2 plus 2, which is negative 5. Notice they are both not equal to 0. So we did that quickly and eliminated 1 and -1 very quickly, which means now there are 4 roots to try, and 2 of them are negative. Now, not only are there 2 roots to try, one of the things that happen when you think about graphing, when I go to plug in P of 1, I'm going to get a number up here at 3. And when I take -1 and I go down to -5, somewhere, somehow, there's going to be a crossing of this, of the x-axis. I don't know where, but somewhere between that 1 and that -1, it's going to cross the x-axis. So cross between 1 and -1. So it gave us quite a hint. And so I'm going to hedge my bets on probably a -1/2. I don't know. So maybe even a +1/2, but I know I'm going to get a negative. I'd like to try a -2 because it's easy, but my thoughts are I'm not going to get a 0 here. So I'm going to go 2, -3, 2, 2, and let's see what I get. Yeah, that's really far off over here at -30. So if this is happening down here at -30, you can probably bet that nothing's going to happen before -2. Just not sure. I really want to try that -1/2 again because I have a feeling it's going to work because we need another negative. And the other negative was -1/2, -1, which we know didn't work, and -2 didn't work. I'd be very surprised if this doesn't work. I'd be surprised if not equal to 0. So I'm going to start with this 2 again over here, this 2. 2, -3, so it's a different one I'm trying. 2, -3, 2, and 2. So 2, -1, -4, 2, 4, -2. I hit the jackpot. So that's terrific. So now I know one of my solutions is -1/2. This will go faster. With more practice. But what's happening now is I'm talking you through what your head should be saying. The hints. So that will help you better. I'm telling you, one of the good hints is this. If we have this in an XY table and your 1 is 3 and your -1 is -5, somewhere between these two, you are going to see that it crosses that axis between it. Between the 3 and the -5 means somewhere between the -1 and the 1. And that's how I kind of knew the -1/2 was going to work. So you don't have to try anymore in the cubby because now you've depressed it down to 2x squared minus 4x plus 4 equals to 0, which you can just solve this quadratic because you have such a lot of choices to do it. I think I'm going to reduce it and then put it into the quadratic formula. And when I go to put this in the quadratic formula, I get x squared plus or minus, sorry, not x squared. X equals the opposite of b plus or minus the square root of b squared minus 4ac, which is -4 over 2. And I do get that imaginary number working for me. So I get 1 plus or minus I. So one answer is 1 plus I. The other one is 1 minus I. And like I said, one of these was going to work. And it seems that it was this one that's going to work. 0, positive, 1 negative, and 1 imaginary as your answers over here. So with no hints from your teacher, if you can kind of go through these steps and you'll be able to get to this part of it like we said it was going to happen up here. So let's try another third degree one. You can actually go, well, this one has it on page 53 or whatever page you see it on, and then the other ones are going to be on blank pages. And I would also always say that step 0 is that this has 3 solutions, 3 roots, right? So since it has 3 roots, our answer is going to be 1 root, another root, and another root, kind of like a little step 0. So if we're going to do Descartes' rule of signs, my p of x is going to be x cubed minus x squared minus 5x plus 5. And my p of negative x is going to be negative x cubed minus x squared plus 5x plus 5. This also is helpful for the factor theorem to do quickly. When you want to do the factor theorem quickly for f of 1 and f of negative 1. So let's check out the variations in the sign. I've got a plus, minus, minus, plus, which gives me 1 variation and 2 variations. So that means that there's 2 positives or there's 0 positives. We just don't know yet. And maybe you want to try one, maybe you don't. So that's a negative, negative, positive, positive. So there's 1 variation, which means there's going to be 1 negative. Now, I know I've told you that the guarantee with 1 negative means you want to try the 1 negative, but just in case it might not be able to be found, it could be irrational. And that doesn't go in a cubby. So an irrational doesn't go in a cubby. It just doesn't go in a cubby. It does not work for a cubby. But you'll be pleasantly surprised to see that the rational roots will narrow them down. Plus or minus 1, plus or minus 5 over your plus or minus 1s. And that's what I mean by that one over here for your n over d. So that gives you plus or minus 1, plus or minus 5, which might make you think that you've got to try 1 in the cubby, negative 1 in the cubby, 5 in the cubby, or negative 5 in the cubby. You really don't have to try these 2 in the cubby unless you know that they're equal to 0. So what we have over here is we're just going to add the coefficients. Added together. Very easy. So it's 1 minus 1 minus 5 plus 5. Oh my goodness. I think we hit the jackpot already. I think while we're at it, we might as well try the negative 1, which actually gives us 8, which is not equal to 0. So it means we're not going to try the negative 1. Now, because this one works, we actually do have to put it into synthetic substitution. And the reason we need to put it into synthetic substitution is for the reason of depressing the equation. So it probably means we don't need those over there. So we've kind of got an easy problem here. 1, negative 1, negative 5, 5. So 1, 1, 0, 0, negative 5, negative 5, and then 0. Yep, we hit the jackpot. They do match. So now I'm going to depress my polynomial into a quadratic that's called x squared minus 5 equals 0, which is very easily solvable. So that gives me x equals plus or minus the square root of 5. So there's your other positive, and there's your other negative. So notice there are 2 positives, and there is 1 negative, but 1 was irrational, so you would never have been able to get it for the cubby. So that it's always good, you know, you could have tried all your negatives. There would have only been 2 of them to try, so you wouldn't have lost that much time. This is going to be a homework after I post it, but wait for me to post. Okay? So it's in the oral exercises, but it says don't do these directions because it just says list Instead, we're going to do the whole process to solve. Steps 1 to 5 above. And when you actually do these, there's a couple of these extra pieces of paper for you to use if you want to, or you could just write out your own. All right, so we did 2 cubics. Now it's time. And by the way, if anybody wants to know what this looks like, if you were to graph it, the end behavior would look like this. You'd have 2 positive answers, and you'd have this negative answer, and this would look something like this when you go to graph it. It's just, I'm not sure what the square root of 5 is right at this moment. I think it's negative 2 point something. So here's your square root of 5, comma 0. This would be your 1, comma 0. And this would be your negative root 5, comma 0 when you're going to graph this. Okay, so let's have some more practice. We can go to any of the pages that you see next. I'm just going to go to page 54, and I'm going to write this equation over here. Now, this one's going to take a little bit longer because it's going to have 4 solutions to it. So when I go to write my answer, there's going to be a solution, another solution, another solution, and another solution. Again, I call that step 0, knowing how many solutions there are. Doing Descartes' rule of signs, P of X, you could actually just do this if you want to, knowing that that's going to look like this. And your P of negative X, if you know that's going to stay the same, you write positive. You know that one's going to change, write a negative. That one's going to stay the same, write a negative. That one's going to change, write a negative. And then that one's going to be a negative. So you're still doing Descartes' rule of signs even if you're not writing the coefficients. But if you don't write the coefficients, this will be harder without coefficients. So sometimes we take a shortcut that really doesn't help us in another way when we're going to do something like this, P of 1 and P of negative 1. So over here I see 1 and 2 and 3. So that means there's 3 variations. So there's going to be 3 positives or 1 positive. And over here there's 1 variation, which means there's going to be 1 negative. If we were to do the chart would look something like this. Let's see how this would look a little off the cuff. I'm doing it real quick. Positive, negative, imaginary. So 3 are 1 with 1 and 1. So that means 0 imaginary or 2 imaginary. So it's going to be some sort of combination of these, 3, 1, 0 or 1, 1, 2. The rational root theorem definitely narrows it down from an infinite amount of potentials, right, to less than infinite. So this would be all the roots of plus or minus 9. Now, all the factors of plus or minus 9. Plus or minus 1, plus or minus 3, plus or minus 9, over plus or minus 2, and plus or minus 1. So this would be plus or minus 1 half, plus or minus 3 halves, plus or minus 9 halves, plus or minus 1, plus or minus 3, plus or minus 9. So we went from an infinite to 12 potentials. But we'll cross off more in step 4, as you'll see in step 4, even in step 3, because we'll see if the ones work or not. So P of 1 would give you these just coefficients, which is very easy to add. You actually should put this number before you say it's not equal to 0, because I do take off for that on a quiz. So it's negative 8, not equal to 0. So at least now we're down to 11 potentials to try in this cubby. So P of negative 1 would be 2 minus 3 minus 7 minus 3 minus 9, which you should write as a negative 20, which does not equal 0. So guess what? Now we're going to write, there's 10 that we could try in the cubby. I'm sure we could narrow it down also. Now, I'm not going to say that when I plug in a 1 and it gets to -8 and a -1 is at -20, I'm not going to say it doesn't cross. It might cross. So in your picture, if you're imagining this picture at -1 at -8, and then, sorry, that's -1 at -20, and then 1 at -8, you might not think it crosses, but it might have crossed. You don't know. Or it did not cross. You don't know. So I can't say that none of these happened between 1 and -1. But if that deters you from trying, 1/2, don't let that be the first one you try. Let it be one of the last ones you try. So I could try, I'm not going to try the 1 or the -1. Maybe it's nicer to try the 9 or the -9 or the -3. But I got to tell you, if -1 is giving me -20 down here already, I really think that -9 is going to give me something down here. So if I'm going to try a positive, I'm either going to try 3 or I'm going to try I'm going to try 9. So if I try the 3, let me see, what do I get? 2. I don't have the answer keys on all of these, so it might be, I might go like a little slower. Let's just see. And I don't have my calc in front of me. 6, 18, 11, 33, 39, some high number. What's that? 120. I think it's 117, 112. That's very high that I really might not try 9. Trying 9, I don't know. Maybe, maybe not. Let me try for this -3 and see what happens. So with the -3, I still have, so this is gone. So I'm now going to go 2, 3, -7, 3, and -9. I'm hoping for a 0 here. It seems like this is going to be the one that works. 2, -6, I'm already feeling it. 9 and 0. And here I hit the jackpot. So -3 is one that works. Now, because there's only one more negative, one negative, do not try a negative here. Do not try a negative. You're going to want to try a positive, because I think what's going to happen is what did we say about the positives? That there'll be 3 positives or 1 positive, but we got our 1 negative. So with our 1 negative, which we got, it's either going to be 3 positives or 1 positive, so don't try another negative. Okay, I think the next one I'm trying is, it's either 1/2 or 3/2. Because we weren't sure that 1/2 would come back up far enough to get to the 0, I think I'm going to try 3/2. Okay, so I can do it right from here. In fact, you should do it from here because it'll depress it. So please make sure you're using these as your coefficient. So this becomes a 2, a 3, a 0, a 0, a 2, and a 3, and I got it. I got it. Excellent. So my depressed polynomial is 2x. So here's my other one, was 3/2. So now I have 2x squared plus 2 equals 0. 2x squared equals -2. X squared equals -1. X is equal to plus or minus the square root of -1, which is plus or minus I. So that gives me an I, and it gives me a -I. So I got my answers. If you're curious about what the graph of this looks like, remember the end behavior is up and up. It's going to happen at -3. It's going to happen at 3/2. So my guess it's going to come down. I mean, I'm not really sure what's going to happen. I think that's for sure -9. So maybe it'll pop up and down, but then it'll go up again, because this right here is kind of like your imaginary, I don't want to say your area, but like your representation that it didn't go back up to this. And then it only had 2 real solutions, which were this one and this one. So the 4th degree ones are ones that like you're going to have to depress it 2 times so you can solve a quadratic. Because remember, you can solve a quadratic in any quadratic you can get, you can solve, whether it's through completing the square or zero product property or square roots method or quadratic formula. It's not so easy to say with the cubics. But again, I know I didn't try 1/2, but it might be worth looking at. I don't know. You can always look at it, but my thoughts were after I failed on the 3 that the -3 was giving me a better option for it. Now I know this, like the phone video gives you guys the picture of the whole thing, but sometimes you're going to need to zoom in to see parts of this and, you know, pause and everything like that. So here's my 1 negative, my 1 positive, and my 2 imaginary. And yep, that's this right over here as the possibility from my chart. Okay, let's do one more together before you get assigned homework on it. And the homework that you get assigned on it will be on Google Classroom because I'm not sure what I'm doing yet for the homework. I'm on page 55, but it could be any one of these over here. Any one of them that you could use. Okay, so again, step 0. I love step 0. We've known step 0 from the summer that there's going to be 4 solutions or 4 roots from this. So we're going to probably look for 2 of those roots, and then the other 2 will fall into play by doing the depressed polynomial equation. So we just did step 0. So when we're doing Descartes' rule of signs, we get P of x equals x to the 4th minus x cubed minus 6x squared plus 14x minus 12. And P of negative x is equal to x to the 4th plus x cubed minus 6x squared. I'm running out of room here. Minus a 14x. Minus a 12. So let me just make sure. Positive. Yep, it changed to a positive. This one stayed negative, changed to a negative, and then a negative. So let's check out the variations. That's a plus, minus, minus, plus, minus. So 1 variation, 2 variations, 3 variations. Means that there's 3 possible positives or 1 possible positive positive. When I go to make my chart, or you don't have to make the chart, you can almost like imaginarily make the chart. So this one's a positive, negative, negative, negative. That means there's 1 variation, so that there's going to be 1 negative. So if I were going to do the chart, this is how my chart would look. Positive, negative, imaginary, so 3 or 1 with a 1 and a 1 to add up to 4, so 0 imaginary or 2 imaginary. So instead of trying an infinite amount of solutions, we don't have to try an infinite amount of solutions because we are going to, with our rational root theorem, try to get all the possibilities here. Over plus or minus 1. So we got plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. So 2, 4, 6, 8, 10, 12. So not an infinite amount, 12 potentials. So in those 12 potentials, we're going to do our factor theorem. But our factor theorem, I like to do it with the -1, which is the way you'll do it on the test. You get a 1 minus 1 minus 6 plus 14 minus 12, and that equals -4, which is not equal to 0. But at least now we're down to 11 potential roots. But when we're thinking of it, it may help us to realize, did it cross over the x-axis? So we're going to try P of -1, which gives us 1 plus 1 minus 6 minus 14 minus 12, which gives us a -30, also not equal to 0, but at least now I only have 10 potential roots to try. So my -1 was a -30. I don't know if I want to try any between 1 and -1. I mean, it's certainly possible that there's that it could occur, but I just don't think it's where I want to go to right now. So of my potential roots, who do I want to try? There may be 3 or 1 positives, 1 negative. So who do we try? And you try all these different ones and you're not sure they're going to work. And by the way, don't discount the double roots. Here's what I want to say about that. Say I have 1, negative 6, 14, and negative 12. So I'm going to try this 2, and I get 1, then a 2, then a 1, a 2, and a negative 4, negative 8, 6, positive 12, and then I hit my jackpot. So at least I know I've got one of my positives. By the way, just letting you know, you can kind of do the rational root theorem in your head, or you could do it again, but this time you're going to do it with plus or minus the 6's, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, not plus or minus 4, not plus or minus 12, because they're not part of this new one over here. Now I know I can depress this down, but now look, I'm going to get rid of the 12s and the 4s. So at least now I have less to try. Don't discount what could be a double root, by the way. And the only way to check a double root is to try 2 again. So I'm going to try it again. 2, 3, 6, 2, 6. Unfortunately, what do I get here? Do I get to that? Is that one a 6? And then I get I might have been doing this wrong for a second. So 1, 2, 3, 6, 2. Oops, this is a 4. I knew it. And I got a 10. So it's not a double root. So I'm sorry. This 2, I'm so sorry. That's a 2 right over there, is only one single root for a 2. But now I want to go back to these numbers over here and bring them down because this one didn't work. No one said this was going to be clean. I could have made it very clean because I have very nice notes, but I have to show you that it's a work in progress. So there's the 1 coefficient, a 1, a negative 4, and a negative 6. So who I will put in the cubby now is I want to try a negative now. So the negative I'm going to try is one of these negatives, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, all over plus or minus 1. Okay, so I already tried the 2. And if I want to try a negative, I could do a negative 1, a negative 2, a negative 3, a negative 6. I'm going to try negative 3. I'm going to jump into the word depressed polynomial here. So 3, that's a negative 3, negative 2, 6, 2, I'm getting a positive 2, and this was a positive 6 before, and now it's a negative 6, and I hit the jackpot. So I've got my other negative. So I've got 1 positive, and I got 1 negative. 1 positive, 1 negative. It doesn't mean I might not find 2 more positives, but it doesn't mean I need to go searching for 2 more positives because now I've got it depressed down to an x squared minus a 2x plus a 2 equals 0, which if I put that into the quadratic formula, you would get 2 plus or minus the square root of negative 4 over 2. I'm going to trust that you guys can do your b squared minus 4ac. And you get 2 plus or minus 2i over 2, which is 1 plus or minus I. So that's a 1 plus I and a 1 minus I. And now you have the solutions to all 4. If you were asked to graph this, we ask ourselves, how would we know this? How would we know what it looks like? And I think we can give it a sketch. So our end behavior would be up, up. Our y-intercept would be a negative 12. So there's our y-intercept of negative 12. Our positive root is 2. Our negative root is negative 3. And these are my imaginaries. That after that comes down, and that comes down, and somehow reaches the 12. I don't know how. it's going to pop back up again, but not reach it, and then come back up and down again. Not realizing, I mean, this didn't necessarily have to be the local minimum. It could have come down like this and scooped down and gone up. Who knows? I mean, until you plug in more numbers, you won't know. If you plug in 2, you'll get 0. If you plug in -3, you get 0. If you plug in 0, you get -12. If you plug in your 1, you'll get -4. So that gives you a nice picture of it too. That can help you see what it looks like, because -1 will give you -30. So that's really going to be far down here. So again, those are all the ways that you can try to do these problems. It's kind of a work in progress. These are going to be assigned also, but for now, just wait. So what you just got here are 4 pages of notes. And your 4 pages of notes came from page, I believe, 52, 53, 54, 55, 52, 53, 54, and 55. And I would wait till you go on to Google Classroom to see what the homework is. But for now, those are the notes. Thank you very much. Have a good day.